Okay. So I'm going to give you another example, but this time around, instead of 2 variables, so we are going to talk about 3 variables. But as far as the principle is concerned, it can be more or less the same thing. Okay, so we have to find out the lambda. Lambda is actually L. Okay, so this is example number 3. Example number 3 from your textbook. It said, well, you are given a multivariable function x and then y and then z, and then equal to 2x squared plus y squared plus 3x squared. And what is the constraint? The constraint here, constraint is g and then x and then y, z equal to 2x minus 3y minus 4z equal to 49. So this is the one that is expanding, and this one is the constraint. Okay, so you are not supposed to expanding here, passing this limit. Okay, so we are going to do the same thing, just like the way we did last week here. So the formula itself is actually, well, delta. Well, I just remember that there is this one here. This one is actually, it's not delta. This one here, because it is upside down, we call it nabla. Nabla here. Okay, so nabla is like this, delta is like this. So this one is nabla. Nabla meaning that, well, delta upside down. Okay. So gradient of f, x, and y, z has to be equal to lambda. But okay, the lambda of the gradient of z, and then x, and then y, z. Right. Okay. So we have to read one step at a time. So let's find out about this nabla. Let's find out about this gradient. Okay. Well, based on this one here, I can easily find out. That, well, f partial x, right, can be equal to 4x, right? Okay, so this one we get to 0 because this one is nothing, and then, well, 3x squared is going to be equal to 6x only. Am I correct? No, hang on a second. I think there is something wrong. Hang on a second. I think there is something wrong. It is impossible here. This one is square. This one is square. Why don't you combine? I think there is something wrong. Okay, hang on a second. Let me check my textbook. Okay. I think I covered it up wrong here. Okay, hang on a second. Oh, see, I got it wrong here. So this one is not x, this one is z actually. This one is z here. Right. Everybody okay? Can you see my handwriting okay?
Yeah.
Okay. So this one is x, this one is y, this one is z. So if you have to differentiate with respect to the x alone, partial. So meaning here, well, the one that is matter is this one is 0, this one is 0, next one, okay? And then what happened here, if I have to differentiate the same thing with respect to the y, f partial y is going to be equal to, this is the only one method here. This one's gone here. It's going to be 2y, right? Okay, and then y, f partial z is going to be equal to this, only this one survives. So it's going to be 6z, that's it. Okay, so that's it. And then, well, so we have to find out the gradient of g here. So I'm done as far as f is concerned. I need to find out the gradient of g. So it's going to be here g partial x. Okay, so I have to look at this one. Okay, so this is the only one that survives, going to be equal to 2. And then, well, and then g partial y equal to -3. Right, okay. And then g here, partial z here, equal to -4. Right? Okay. So we have to make an equation from here to here, from here to here, from here to here. So based on that, this line, the setting up here. So we got here. So it's going to be equal to 4x, 2y, 6z, okay, angle bracket, equal to L. L stands for lambda. Okay, angle bracket again here. So I got 2, and then -3, and then -4. Right. Okay. So let's see what happens. So I think that I have three equations. So this one go to here, and this one go to here, and this one go to here. So let's see what happens. Let's do it one by one. Okay. So the first one is that I got here 4x equal to 2 lambda. That is the first one. I am equating the first term and the second term here. Right-hand side, right-hand side. And then I'm to equating this one, the second term, the middle term, to the middle term on the right-hand side. I got 2y equal to -3 lambda. Right, okay. And then the last one here, I got 6z equal to -4 lambda. Am I correct? Yes or no? Right.
Yeah.
Okay. So what is my goal? My goal is to find out what is x, what is y, what is z. Right? Yes. Okay. So in that case here, so let's see what happened. So I think I need to analyze one by one. Okay. Let's do two-way equation. So let's well. So let me do this. Let me do this. Okay. Let me do this. So L here, according to the first term, I got equal the same thing as 2x. Yes. L stands for lambda. Yes. Okay. And then here, according to the second line here, well, L here is actually the same thing as what? Hang on a second. No, I think I need to turn it around. I'm sorry. I need to turn it around. This one here. I think I need to turn it on. So instead of L here, I need to say, well, x here equal to 2 over 4L. Yes. Okay, so I need to turn it on. So this one is going to be equal to 1/2 L. Right. Okay. Now, so let's talk about this one here. This one here, I need to make it happen, make it manipulate it the same way. So y here equal to -3 second L. Everybody okay? Right. Okay. Let's go to the last one. The last one also the same thing here. So I'm going to say that g here equal to long story short, 2/3 L. Am I correct? Yes. So what's so good? Am I correct? Yes. Okay. Now, and once you get this one here, now, so you need to find out what is L, right? After finding the L, then it is easy. The next step is going to be easy. You're able to find out what is X, what is Y, what is Z. Okay. Now, in this case here, whenever the problem here, after you got into this step here, always plug into this guy. Did you see it? Always plug in this side. Okay. Because this one is the only one that of a relationship between X, Y, Z. Right? Okay. So go ahead and plug in here. So I got here. So it's going to be 2 here. Well, what is X in terms of lambda? X in terms of lambda is 1/2 L. Yes or no? Yes or no? Right. Okay. Now, and then after that here, -3. Okay. What is Y in terms of lambda? Well, it's going to be this one. Excuse me. It can be -3 second. -3 second L. Can you follow me? Yes or no? Right. Okay. Now, so let's talk about the last one. The last one is -4z. Okay. What is z here? According in terms of lambda. According to lambda here is -2/3. Okay. 2/3 lambda. Okay, so this one here, the total left-hand side equal to 49. Yes, are you okay with my handwriting?
Are we using the G function because it has an equal to 49 in it?
Yes, yes, because
Oh,
this one
okay.
is complete, but this one here, I'm sorry. Okay. Forget about it. Yeah, that's correct, Sophia, because we want to use this one simply because that this one is nothing. This one is, well, I don't have anything here on the right-hand side, right? But this one here has a complete relationship between x, y, z, and 49.
Okay, got it.
Got it? Okay, so always plug it into the constraint. Never plug it into here because this one you don't have anything at all. But here you got something like this.
Okay.
Yes. Okay. Now, so let's see what happened here. So this one is a nice number. So I get here L plus 9 second L, right? Okay, and then plus 8/3 L equal to 49. Yes. Yes or no? This one become positive, this one becomes positive because we got negative. Yes, okay. Now, and another here. So look like here, I have to multiply by 6, and because I would like to, well, yeah, I think multiply by 6. Okay, left-hand side, right-hand side. So if I multiply by 6 here, so this one becomes 6L, and then this one here is going to be, well, meaning that 9, I have to multiply 9 by 3, am I correct? Yes?
Yeah.
Okay. So it's going to be 27L, and then here I need to multiply 8 by 2, because remember here I multiply left-hand side, right-hand side by 2, 16L, and then somebody help me, what is 49 times 6? Somebody help me? What is 49 times 6? 49 times 6?
Hang on, I'm plugging it in. 49.
I have a calculator.
294.
294, yes. Okay. So in this case here, so what you got here? Well, this one is 6, and this one is 27. It's going to be 33. Am I correct? Yes or no? Yes?
Yeah.
Okay, 33 here, so 16. It's going to become 49. Yes or no?
Everything over 6 though, right?
Yes, multiply by 6. Multiply by 6, multiply by 6.
Yeah, but everything is gonna be over 6, or you're just canceling.
I'm just canceling it.
Oh, okay.
So I multiply all of them by 6. So if I multiply this one by 6, it becomes 6L. And this one here, well, the 6 and 2 here canceling out, so it's going to be 3.
Okay. Okay, got it.
It's going to be 33 plus 16 is going to be 49, right? Okay. Okay, I hope that I'm getting a good number. 49, L equal to 294. So L here equal to 294, 49. Do you think this one here, we can come up with a nice number on it?
It's 6.
What?
It's just 6.
Wow, that's good. It's a good number, Sophia. 6, am I correct?
Yeah.
Yes. Okay. So based on this one here, so what you got? Well, after I got 6 here, so the next step is going to be very easy because all you have to do is just go back into here, right? Okay. So meaning what? Meaning here, well, it's going without saying it. X here is going to be equal to 1/2 6 equal to 3, right? Okay. And what is y? Y here is going to be equal to -3 second times 6 going to be equal to -9. Okay. And what is g here? Well, g here equal to -2/3 times 6 equal to -4. That's it, right? So what you got? Well, so meaning here. So I think we got maximum here. Where the maximum here is at a particular point, which is 3, -9, -4. Okay. So remember here. So do you think this one is the value of extrema? Do you think? No, this is just only the location where it happened here. Well, how do you find out the extrema? Well, you need to take all of this and plug it into what? This one or this one? The first one. Okay, remember here, the second one is actually just a constraint. The one that is limiting its growth. Okay, so
How would you know that it was a maximum though?
remember I told you yesterday here. So in this problem here, the problem never asks you what is maximum, minimum, never, because because a lot of situation here it is actually inherent.
Okay.
Is inherent. Do you understand what that means by inherent? Inherent is that, like I said, what is the smallest distance? What is the smallest distance between A and B? Nobody is going to ask you what is the maximum distance from A and B. It doesn't make sense.
Okay.
So if you have to find out the distance from A to B, from point A into, let's say, a line L or whatever here. So you're looking, of course, that it is what we call inherently minimization problem, because it's impossible to find the maximum. It's unlimited.
Okay.
Yes.
Okay.
So, okay. So if you plug in all of this here according to my note here, so it's going to be equal to, well, F3 -9 -4 here is going to be equal, according to my note here, 147. Okay. So what is this one? Well, this one is actually the extreme one here. Okay, makes sense?
Okay.
Everybody okay? Am I good enough? My voice is good enough? Okay. Okay. So let me take a moment to take a pendant. Okay. Horacio is here or not? He's not. Okay. Adrian is not here. Thomas is here. Thomas. Well, he doesn't respond, so I'm not going to check it. Okay. And then Mina is here. Mina.
Yes, sir.
Horacio. Okay. So he's here, but he didn't respond to my calling. Okay, so I need to skip it. Ethan is here. Ethan? No. Okay, Forrest is here. Forrest? Okay, remember here, if I call you out, if you did not respond, even though I see your name here, but it doesn't count. I'm sorry. Claire is here. Claire, can you respond to me? Claire? Okay, I need to skip it. Young-san? Young?
Here.
Okay. Tyler? Here. Okay. Remember here, if I see your name, your name only is showing up on my screen, doesn't count. So I need to call you, you need to respond. Okay. Marco, are you here? Marco?
Yep. Yeah, I'm here.
Okay. Timmy, are you here? Timmy? Are you here or not? Okay, Timmy? Well, Brad, are you here? Brad? Jack?
Yeah, he said his mic doesn't work.
The what?
His mic doesn't work.
Okay.
Yeah, he should be there.
Yeah. Okay. Jack is here? Jack is not here, right? Okay. Joseph?
I'm here.
Carlos? So I didn't see Carlos. Okay. Sophia?
Yes, sir.
Jared? I didn't see Jared. Okay, so let me repeat one more time. Horacio, are you here or not? Horacio? Okay. So I call you second time for the second time here. Thomas? And then Ethan. Ethan is not here. I didn't see his name. Okay, Claire. Claire.
Yeah, I'm here.
Okay. Okay, and then Jack. Jack is not here. Carlos. So this is the second calling here. Carlos. Carlos. Okay. What did you see? Okay. So I need to call you. I need to make take attendance again, maybe by the next. Later on. Okay, for the second time. Okay. Okay. There is one particular problem that I need to explain, okay, because that problem is kind of very, very particular. So can I erase it? Everybody okay? So keep in mind, I need to take attendance again about 1 hour from now to make sure that everybody is here.
Okay.
I don't want you just showing up on screen also, but physically you are not here. So that's something I don't want. Okay. So the example I'm going to give you is actually coming from exercise, not example. Oh. Okay. So this one here is exercise. This one is not example, but exercise number 21. Number 21 here. So the question is that, well, what is the shortest distance here? Okay. Shortest distance from 0.2, which is of course a point here, to x minus y equal to 4. Okay, so this is, well, so if you draw a rectangular system y, let's say this one is x, so let's say, well, so this one is going to be x minus 4, y equal to x minus 4. So I think that is going to be something like this, perhaps. Right, okay. 0, 2 is actually here, maybe 0, 2 is here, so also over here. So we need to find out what is the shortest distance here from this point, 0, 2 here to this line. Okay. Well, so first of all here, so we remember the formula for finding out the distance based on high school here is, well, d here equal to square root, right? x1 minus x2 square plus y1 minus y2 square. Am I correct? Yes or no? Make sense?
Yeah.
Okay. But here we have to make an exception, not because that we would like to make it simple for no reason, but we would like to simplify here without affecting the result. So if you look at this one here, so this one is square root. Okay, so remember here, if you have to find out the derivative of square root, is actually a pain in the neck. Am I correct? Yes. Okay, it's very, very difficult. But let me continue. Okay. So in this case here, I don't know. So let's do this. Okay, so this one is 0, 2 here. And this one here is x minus y equal to 4 here. I don't know, where is it here? I don't know. I think that's going to be maybe here. I don't know here. I don't know what it is. But for the time being here, can we just say that this one is x, this one is y here? Because I don't know here, just represent the coordinate of the shortest distance here at this line here is x, y. Can I? Right? So knowing this one here, so I can easily find out here. So this one is a b, correct? The b here, of course, according to this formula that from high school, the b here is going to be equal to the square root, okay, and then x minus 0 square bracket, yes or no? Yes, this one is x. This one is x2, yes or no? Right? Okay.
Yeah.
And then plus y minus 2 0 and minus 2 square. Right. So simplify here is going to be equal to x squared plus y minus 2 square. Yes or no? So this is b. Okay. So remember here that the formula for getting Lagrange multiplier is, well, so it's going to be here the gradient of f x y equal to lambda g, and then, well, gradient x y. Am I correct? Yes. So meaning here, if I had to take this one here as the f here, okay. So meaning here, I have to find out the gradient of this one. But having the square root is very, very difficult. But it's pain in neck. It's not impossible, but it's very difficult. But in hindsight, I see that, well, so this one here, the square root is actually nothing. Because if I'm able to minimize this one here, square root is going to be minimized, am I correct? Yes or no?
Yes.
So I don't have to worry about the square root here, because square root is actually unnecessary problem, unnecessary difficulty. Can I just put it aside here? Because my thinking, my logic, my reasoning is that if I'm able to minimize this one, of course the square root is going to be minimized. Did you see? So in this case here, so I need to find out the gradient of not the one that have square root, but without the square root. I'm just focusing only the one that is inside. Okay. So in this case here, so what is that? Well, I'm going to say that. So let me represent this one here as the f. Let's say. Okay. So remember here, f here is the one that is representing the one that's inside, not including the square root, because I would have to get away with square root, because square root is unnecessary difficulty, unnecessary step that it's not important at all. So I'm going to say f x y here equal to x squared plus, okay, y minus 2 squared. Right. Okay. So if you want to, you can expand it, become x squared plus y squared minus 4y plus 4. Okay, so let's do it one by one. Okay. So this one here is the function here, and what is the constraint? Well, what do you think? What is the constraint?
X minus y equals 4.
Good. That's it. Makes sense or not? Because whatever you do, whatever you come up from this equation here, the relation of x and y has to be fixed by this one, am I correct? So I can say this one is nothing but constraint, yes or no? Is it or not?
Yeah.
Yes? Okay, so let me repeat one more time here. So whatever you come up from this one here, okay, so has to be constrained by this on the relationship. You cannot be less than x minus y equal to 4. You cannot be more than x minus y equal to 4. You have to be exactly x minus y equal to 4. That's it. So I'm going to say that from a different perspective, this one is nothing but constraint. Right? Okay. So in this case here, so it's going to be g x y here. This is the constraint equal to, okay, x minus y equal to 4. That's it. Okay. So let's do it one step at a time. So first of all here, I am going to find out the f partial x here, f partial x will be equal to only 2x. That's it. Okay. Now, so let's go for f partial y. F partial y will be equal to, okay, it's going to be 2y minus 4. That's it. Right. Can you follow me? So everybody okay? When I say that, well, this one is actually a constraint, yes or no? Everybody okay? Do you have problem understanding? Yes, makes sense. Okay, so let's go for another one here. Well, the next step is in the G here, because this is what we call the constraint. So G partial x is going to be equal to just only 1, right? Okay, and then G here partial y here is going to be equal to just 1, negative 1 here. Okay, so we are going to make an equation, the first line and the second line. Okay, so we've got here it's going to be, well, 2x comma 2y minus 4 angle bracket equal to L lambda opening angle bracket 1 comma negative 1. Right, and again I'm going to make a corresponding equation. First term, go to the first term, left hand side, right hand side. Second term, left hand side, right hand side. Second term, second term. So eventually what you get is that 2x equal to lambda only, right? Okay, and then 2y minus 4 equal to negative lambda. Right. Okay. So and then again here, whatever you got here, you need to plug it into here. So here, you remember, right? So this is always come to the rescue. You need to solve this one. Okay. So so let's do it. Okay. So x here equal to L divided by 2. Right. Okay. And then y here is going to be equal to equal to okay minus L plus 4 divided by 2. Yes. Okay. So this one here is going to be equal to negative 1/2 L plus 2 only. So this one is going to be equal to 1/2 L. Okay. Okay. Once I'm quite satisfied with the x equal to something something L, y equal to something something L here. So let's plug it into here. So I'm going to do it. I'm going to do it here. Okay. X here is going to be 1/2 L minus negative 1/2 L plus 2 equal to 4. Okay. So I got here 1/2 L plus 1/2 L minus 2. Correct me if I'm wrong, because I open up negative here. This one become negative. Excuse me, become positive. This one is negative here. Equal to 4. So look like I got L here equal to 6. Okay, I got another nice number, 6. Right. Okay. So what you got? Well, based on this one here, I can easily find out what is the x, what is the y. The x here equal to cross. So 1/2 times 6 equal to 3. Right. So what is y? Y here equal to, okay. So it's gonna, this one is gonna be negative 3 plus 2 equal to negative 1. So what is the point? The point here, of course, is gonna be 3, negative 1. Okay. So what is the value of the smallest distance? Well, the value of the smallest distance here is going to be, which one I have to plug in? Somebody tell me. So I already got
The first one, the distance one.
okay, the distance, right? With or without square root? With or with?
With?
Yes.
Yeah.
Yes. Make sense or not? Okay, I take out the square root simply because it's to make my life easier, make your life easier. But as far as finding the distance, the real distance is concerned, you need to plug in the square root back, right? Because, well, that is the proper formula for finding out the square, the distance, correct? Yes or no?
Yeah.
Yes. So eventually, if you plug in everything into here, so eventually here, go ahead do your own calculation here. So you got here, well, the d here is everywhere equal to 3 square root of 2. You can double check with the text. Make sense? Everybody okay? Yes.
Yes.
Good. Okay. Any questions so far? Okay. Okay, I think that concludes our topic, our discussion about Lagrange multiplier. Okay. So, and then after that here, after we finish this one here, we embark on a totally new chapter, totally new animal. So this, the next one here is going to be a little bit complicated here, but it's not unsurmountable. So just be patient, just follow my discussion step by step here, and you should be able to get it, okay? Can I erase it? Can I erase it? Okay. So the next section here is actually talking about integral again. Okay, so this one here, it is 14.1 here. This is what we call iterated integral. Okay. Well, in plain, simple English, what does it mean by iterated? What does it mean? What does it mean by iterated? Iterated, remember? Okay. How about reiterate? What does it mean by reiterate? Repeating. Yes or no? Make sense or not? Yes? Can you hear me? Everybody?
Yes.
Yeah.
Okay. So iterated is that actually nothing but repeated. Okay. Well, so let me give you a general idea. Okay. So this is totally new concept. This one here that doesn't have anything to do with our previous discussion. Brand new, totally out of blue, out of nowhere. So remember here in the past, since calculus 1, calculus 2, and then up to this point, calculus 3 here. So when you talk about integral is going to be like this. Yes, no. Okay, so it's going to be, well, f, df. Am I correct? Yes or no? Okay. Now, from now on here, okay, we are going to talk, well, so how many, this is the notation for integral, am I correct? And in fact here,
Yeah.
this one is what we call elongated. Well, this is what we call, well, this is summa. Okay. And of course, there's some people who say that this one is actually stylized, or what? I think it's going to be, some people say elongated S. Okay, here. So we get only one, right? Okay. So from now on here, so we are no longer talking about one. We are going to talk about, well, double integral. Okay. F here, dA. Okay. And then after we finish with this one here, we're going to talk about something else, which is, well, triple integral. F here, well, say dV. Okay. Well, first of all here, so this is what we call iterated integral. Iterated integral. And this one here is what we call double integral. Okay. Don't worry about what does it mean by A here. This one is going to be R, and this one also going to be R here. Don't worry about what does it mean by V for the time being. Just accept it as it is, because eventually here I need to explain in detail about what is the difference between A, what is the difference between the A and the V. Okay, so this is what we call triple integral. Okay, triple integral. So this is double integral. So this is triple integral. Okay, so what is the purpose? Well, the purpose here, this one is finding out find the volume. Excuse me, area. Okay, so it's going to be 2 dimensions, right? Okay. Now, so what is the purpose of double integral here? Double integral here to find out the volume. To find out the volume. Okay. Triple integral also the same thing. You need to find you need to use them to find out the volume. Okay. So what is the difference between double integral and triple integral? Well, double integral is useful for finding out the volume of like something like cylinder, something like this cylinder here. Did you see it? Okay. Or maybe that something like this perhaps. Okay. Anything that has a shaft. Okay, cylinder, like cylinder. So maybe that it can be like this perhaps. Something, anything that look like cylinder. Remember here that on the first week or the second week of this semester here, I talked about that we have an expanded definition of cylinder. Remember in Calc3?
Yeah, it's anything that is expanding.
Yes. Anything that has a shaft that's long, so on somebody is going up, down here, this is what they call cylinder. Remember here in high school that we have a very, very limited definition of cylinder. Cylinder is whenever the base is complete, good circle, and the top one is also regular circle. That is what we call cylinder. Right? But here we are talking about something that is actually an expanded, generalized definition of the cylinder. Right? Okay, now, so triple integral is useful to find out sphere, like that, right? Okay, but for the time here, do not worry too much about what is the use of double integral, what is the use of triple integral here. Let's focus on this one. Okay, now, for those of you who come across this section for the first time, that you couldn't have, I think that you couldn't have asking, well, we learned quite a lot finding out the area here, area in Calculus 1 and also some in Calculus 2. Why do we have to learn again here, iterate the integral, finding out the area? Okay. The answer is, well, you are correct. So this is iterated integral, it's just only for learning only, learning. Okay. So I'm going to say that this one is a transition. This one is nothing. This one, maybe this one, the textbook intentionally include this one before we do double and triple integral, because in order to, I think maybe just to adjust your mindset perhaps, whatever here. So, well, this one is just only for learning moment here. So I guarantee once you graduate and become an engineer, you're not going to see it again. This one is just only for the bridge from the regular integral into double integral, triple integral. Okay, makes sense? Yeah, so this one is just only for learning moment. So it doesn't exist in your professional life in the future. This one exists, that one exists. You're going to use this one quite a lot. You're going to use that one quite a lot, but as far as this one is concerned, this one is only a bridge from here going to something that is totally new. Everybody okay? So I'm going to say this one is a transition. Yes. Everybody okay? Yes. Okay.
Yep.
Okay. Now, so this is a very, very big subject. Okay. So let me. Okay. So let me give you the first example. Okay. So look like the textbook is giving you introduction into double integral, triple integral step by step. Look like the textbook doesn't want to scare you off, because this one is pretty heavy subject. Okay. So let's go for example number 1. Example number 1, again, the number 1 is this kind of gentle introduction. Gentle introduction. So it said, well, can you evaluate, okay, integral 2x squared y squared plus 2y and then dy. Well, it's very simple, am I correct? Yes. The only difference is that, well, so this one is 1, but this one is x. This is. So remember here, up to this point, every time you do definite integral, so this one always a whole number, lower bound. The upper one also a whole number, like that. But here we are talking about this one is a number, but this one is what? This one is actually variable, right? Okay. So how do you do it? It's the same thing. Okay. Well, so it's going to be here, okay, 1x, right? Okay, remember here we are going to integrate with respect to the y. So in this case, so this one is considered as a constant. So it's going to be 2x, okay, and then 1/3, and then y/3. Yes, because we are integrating with respect to the y. So this one, this one here, we have to get in. I mean, we have to deal with it. But this one we have to consider it as a constant. Yes. Okay. And then plus, okay, 2 second y squared, isn't it? Yes. Right. Okay. So it's going to be equal to, okay, 2/3 x y cubed plus y squared and then 1x. Right. Okay. So how do you get into? Well, of course, first of all, you need to plug in x into which one we have to plug in? X, you need to plug in into the x, or x, you need to plug in into y?
Into y, right? Because that's
yes,
part of
because at the beginning, that it is specifically asking you to integrate with respect to y, right?
Yeah.
So if you have an x and y inside here, of course you need to plug in x, whatever it is, into the y here. Okay, the x is just only a bystander. Right? Yes, everybody okay? Okay. So it's going to be here 2/3 x times x cubed, right? Yes or no?
Yes.
Okay, and then plus x squared method.
Yep.
Okay, so we got this going to be 2/3 x to the 4th plus x squared. That's it. Okay. So let's do the second one. The second one here is going to be equal to 2/3 and then x y cubed, using x1 cubed, sorry. Okay. And then plus 1 squared can be equal to 2/3 x plus 1. Right, okay. And then go ahead and subtract it. Subtract, and then you get the result. Am I correct? So what is that one? That one is actually, if you solve the definite integration here, but the lower limit is actually a whole number, but the upper limit is a variable. Okay.
Okay.
So this one is nothing here. This one is just only a gentle. Do you understand what I mean? A gentle introduction into the concept of multiple integration, because we got more than one as multiple integration. Okay, makes sense? Okay. Now, so
Excuse me.
Yes.
So the answer is 2/3x plus 1.
2/3.
What's the answer?
The
Because
answer,
integration.
the answer here is going to be 2/3 x to the 4th plus x squared, which is the top one.
Oh, I think there's a mistake
Minus?
for integration.
The what?
Integration, there's a mistake.
Which one?
The second line.
Oh, this
So,
one.
Yeah.
Okay.
No, why that -2? The integration is not that you just differentiate it.
Oh, this one is correct. This one is 2 and then
No,
1/3.
you have to integrate, but you did differentiate. I'm so sorry. I
What?
think, yeah,
What do
we
you mean?
need to integrate, but you did differentiate, right?
No.
No, he integrated.
No,
No. Yeah, we have to add 1 when we integrate.
Yeah,
Not,
that's what he did.
no. It was
What do you mean?
negative 2, so it should be -1 if we add 1. And so it should be -1/1, right? We have to add, right?
Yes, you
Yeah.
have to add. So that's why this one is
So
2.
it
This one
was
is
a -2, right?
no.
Why is it -2?
Which one?
Isn't it -2?
Which one -2?
The why?
No. So
Yeah,
this
yeah.
one.
Why don't you check the question? It was -2.
Yeah, okay, then that's fine. That's fine. Okay. But again here, so as far as this one is
So is
concerned,
it 2? Y
this one
square?
is 2. This one is 2.
Square? Okay.
Okay. And maybe that I copied it wrong here, but again, as far as the step
Okay,
here, according to
okay.
this one is correct. Okay. So of course
Okay.
that this one is wrong here. This one here I should put in square here. I should put in, so this one is gonna be the fifth. So this one here is gonna be square. That's it.
Okay.
Okay. So maybe I copied it wrong, maybe. Okay.
Yeah,
Maybe
yeah.
the
Okay,
-2,
that
that's
makes
fine.
sense.
That's
Okay.
fine. That's fine. Okay.
Yeah.
Okay.
Professor,
Yes.
when
Yes.
we're integrating with dy, that means we also have to integrate the x.
No, you don't have to. You don't have to. This
So
one
then
is
it wouldn't.
Yeah.
So then
But
it
this
would be
one-
the
That
x squared.
makes sense.
Yeah, this one here should be considered as a constant.
Okay,
So
that
yeah.
makes
So,
sense.
so this one is considered as a constant.
All right.
Nothing.
Okay.
Okay.
So it wouldn't be x squared. Got it.
No, the only thing matter in the I of the y here is going to be y only.
All right.
So this one
Just
also the
making
same thing. Makes sense? Okay. So let's go for a break first. Okay. So I give you about 5 minutes or 10 minutes break here, and then come back here, and then we continue with the example number 2. Okay. Everybody okay? Okay. Remember here we are still talking about iterated integral. Iterated integral is nothing but introduction, a gentle introduction into the concept of multiple integral. What does it mean by multiple integral? Is an integration that has more than one elongated. Okay, so go ahead, take a break, go to bathroom, restroom, eat something to have. Okay, okay.
Professor Petra,
Mhm.
how are we going to take the exam?
It's gonna
The
be online.
online?
Yeah, online. Okay, so I haven't decided yet. Okay, because I'm
I
still
see.
waiting for a guideline.
Then are we going to use the same assign.net, or are you going to make exam problems?
It's gonna be a mix. The one that I pick up from WebAssign, and also some of them is gonna be that I make it myself. Okay.
It's timed like that.
Yes, it's time. So
Oh,
so I need to time it.
I see. As for me, it's hard to read the screen instead of a paper.
Mm-hmm.
It's hard to focus on the writing on the screen. It's
Yeah.
really,
But
yeah.
we don't have any choice because
yeah.
so we're not supposed to come back to campus, so I don't know what to do. Okay, and
Yeah.
especially the final, I don't know, to be honest with you. Okay, everybody's here. So let's get started again. Everybody's here.
Yeah, I think.
Okay, here. So let's go for the second example. The second example is kind of too long here, too complicated here. I'm just going to make it simple. I just make up the problem myself. Okay. So what it says is like this. Okay. So this is example number 2. I do not copy exactly as a textbook. So it's a 1 and 2, and then and then integral 1x, and then x squared, let's say y squared, and then d. So this one is dy, and then close bracket dx. Did you see it? Right. So this is what we call inner integral here. So this, the one that is inside, elongated s plus dy. So this is what we call inner integral. But the one that is outside is this one. Did you see? So this one that you have to link up, you have to match with this one, the one outside. Outside dx, and outside elongated s, and this one is inside. So I'm going to say this one is the inner integral, and this one here is outer integral. So this one is inner, this one is outer. Can you see? Right? Mm-hmm. So the principles were the same thing, just like pandas. Do you still remember what does it mean by panda? Pandas. Do you remember what does it mean? So basically what it says is that P stands for parentheses. Am I correct? Yes.
Yeah,
so,
it's the order of operations.
Yes. So P is actually, well, whatever that is inside the parentheses, you need to do it first. Okay. So the same thing here. So this is the one that is inside the parentheses. So you need to deal with this one first. After you finish with this one here, and then you can just go ahead and deal with the one that is outside. So this one is inner integral. This one is outer integral. Okay, makes sense? Okay. So so I'm going to say that inner integral here, inside I here. So okay, so it's going to be integral 1x squared y squared dy, okay, can be equal to, okay, bracket 1x and then x squared and then 1/3 y cubed. That's it. Okay. So this one here, if you break it down into the upper limit and lower limit, so we got here so 1/3 and then x squared times x cubed, right? So it can be equal to 1/3 x to the 5th, right? And then here, and then if you plug it 1 into here, so we got here 1/3. Sorry. So 1/3 here, 1 squared. Okay. Oh, sorry. Okay. So x squared. Okay. And then 1 cubed. Right. So it's going to be equal to 1/3 x squared. Right. So if you subtract this one from here, so we got here, well, it's going to be equal to 1/3 and then x to the 5th minus x squared. That's it. Right. Okay. So this is what we call inner integral. Once we finish with the inner integral, just like the concept of pandas here, so you need to plug in again and deal with the one that is waiting outside. So this one is outer, this one is inner. Okay. Okay. So what's it got? It's going to be the outer integral. So we got here integral, okay. And then, well, let's put the 1/3 outside because 1/3 doesn't have any relevance at all. X to the 5th minus x scan second here dx. Right. Okay. And this one 1 and this one is 2. Did you see it? So the way you do it is that you need to deal with the inner, just like the concept of pandas. So you need to deal with the one that's inside and going outside, expanding outside. Yes, everybody okay? Yeah. So and then here and then so I'm going to do well, it's going to be 1/3, okay, bracket, 1, 2, right? Okay, so it's going to be 1/6 x to the 6. Yes, okay, it's going to be minus 1/3 x to the 3rd. So, can you solve it? Can you solve it? Yes, very simple. It's just a matter of arithmetic. Okay. So again, here, these are just only a gentle introduction into the concept of multiple integration here. But the one that I would like you to pay attention early on from the get-go is that this is, like I said before, this one is what we call the inner integral, and this one is outer integral. Am I correct? Yes. So did you see that? Well, when you talk about the upper limit here, so this one is variable, and this one is constant. So it is actually a rule that you need to remember here, that whenever you have upper or lower limit here, that they are not variable. It always happen only in the inner integral. It never happen on the outer integral. So do not expect to have outer integral. So this one, let's say, this one is x, let's say. Okay, it's impossible. It's impossible, because if you insist on having a non-constant variable or variable here as the upper or lower index on the outer integral, eventually that you are not going to get any result at all. And eventually the result is going to be another variable, which is actually doesn't make sense, right? So from now on here, you need to get used to the idea that when you talk about x or y or whatever here, the upper limit or lower limit here, it's always happen inside. Always happen in the inner integral. It never happen on the outer integral. Or the other way around, you can just remember that when you're dealing with outer integral always having upper limit or lower limit, whole number. Never variable. Never variable here, never variable here. Always a whole number, not whole number, constant, a number here, and it's also a number. Never variable. Variable happen only inside. You get it? Inside. Okay.
Got it.
From now on, you need to memorize that one. Because eventually, well, again, here, if you ask me why, well, because here, if you have variable outside, eventually here, if you plug in, let's say 2 is, and this one is not 2, let's say x here, let's say a or whatever, eventually you got variable. It's actually, doesn't make sense. Yes, okay. So let me take a pen of one more time. Okay. So Horacio is here or not? Horacio?
Come on, man.
Horacio. Okay, I didn't see you. Okay, so I'm not going to check you. Adrian is not here. How about Thomas? Thomas is here. Thomas? Oh. Okay, Mina is here.
Yes.
Ethan is here. I didn't see Ethan. Okay. And then Forrest, are you here?
Here.
Claire, are you here?
Yeah, I'm here.
Okay. Young is here.
Yes.
Tyler is here or not? Tyler? Tyler?
Yeah, I'm here.
Marco, are you here?
Still here.
Timmy, are you here or not? Timmy. Okay, so this is the third time I called you, but you didn't respond. Jack Thomas, not here. Joseph is here. Joseph?
Still here.
Okay, Carlos is here or not? Carlos? So I didn't see you. I didn't hear you. Sophia is here. Sophia?
Hi.
Jared is not here. Okay, that's it. Okay, so let's go back. Everybody okay? Any questions so far? Again, here, this one is nothing except just a general introduction into the idea of multiple integration. Okay. Okay, so let's go for the next example. Okay, so we're going to step up into something which actually makes a lot of sense. Okay, here. So I would like to give you an idea here. Just keep in mind that this section is very long. The reason is that, well, I don't want to rush it because this one is very important. Like I said before, this one is actually a gentle introduction into the concept of multiple integration. So let me off the script explain something to you. So this, the one I need to talk about is actually belong to calculus 1, which of course that you should be an expert by this time around. So this one is Y and this one is X. So let's say that if you have a graph, so this is the Fx, okay, and you got another one which is this one here, let's say this one, okay. So this one is, let's say, Gx, okay. Now, so how do you find out the area between the first curve and the second curve between G and F? How do you find out this?
The integration of 1 minus the integration.
Okay, so which one is the top one? Which one comes first?
The F1, right?
Okay, so if you have to find out, let's say that this one is A here, so this one is B, okay. So the setting up the integration is going to be starting A from the, this is the lower in limit and this one is upper limit. So I got here Fx minus Gx dx. Everybody okay? So this one here comes second simply because this one is actually the bottom one, the lower one. And this one comes first because this one is on the top. Everybody okay? So this is what we call area between two curves. Yes, very simple, very, very simple. Okay. Now, if you look at this one here, okay, if you look at this one is what we call the regular integral. So meaning what? This one is actually what we call as a simple integral, just only one integration. Okay. Now, so I would like to use this one to introduce the idea of what we call double integral. Remember here in this section, the title is a iterated integral. This one we are supposed to find out the area. Okay. Now, so do you understand? Do you think that you can follow my reasoning? If I say that this one, I can convert this one into double integral. Oh, so it's going to be like this. Okay. A, B, okay. So the same thing. Okay. Now, instead of one integral, so I will transform into two integrals. Yes. Integral again. Okay. And then Fx Gx dx. Does it make sense to you? Okay. Does it make sense to you?
Yeah.
Yes or no? Yes or no? Does it make sense? Does it make sense to you now? Okay, so first of all here, so let me explain. Okay, the reason I am changing F to P here, I just don't want to confuse, but as far as the meaning is concerned, it's the same thing. I just want to confuse with the BF. Why they are the same thing? Why? Because, remember here, you can easily here say that, well, remember here, this one is double integral, right? So double integral meaning what? Meaning here, we have to solve the one that's inside first. Am I correct, Emma? Yes or no? Right.
Yeah.
Right.
Okay, so meaning here, if I am solving the one that's inside here, F, T, and then G, T, B, T. Okay, so this one here, that since this one is 1, am I correct? Yes or no? Sorry, this one should be active. Yes or no? Everybody okay? This one is actually 1, am I correct?
Right.
So if you integrate 1 here, so you end up having T and then F, X, G, X. Does it make sense to you or not?
Yeah.
Yes or no? Make sense or not?
Yeah, but
Yeah,
in the
makes sense.
double integral, what are you actually integrating?
What do you mean?
What you're gonna integrate are the functions themselves, or?
No, I'm integrating this one. 1.
Oh, okay.
Because
Okay.
this one here, because this one is an upper limit.
Oh, makes sense now. Okay.
Okay, so this one is lower limit here. So I think that I write it too crowded. Yes or no? I'm integrating 1 is equal to T, am I correct?
Yeah.
Make sense or not? Okay, now, and then after that here, if you plug in Fx, upper limit, Gx here, lower limit, eventually here, so what getting is Fx minus Gx, am I correct? Yes? It is it? So if you, after you finish with the integral here, so you have to supposed to plug it into here. So it's going to be coming back exactly just like the way we did in calculus 1. So that is the idea of double integral finding out the area. Yes or no? So I'm going to give you a couple of seconds to digest because this one is totally brand new to your idea. Yes or no?
Makes sense.
Yeah.
Makes sense or not? So basically here, this one here is actually calculus 1, but here we are going to force ourselves converting this one here from single integral into double integral. So we have to do like this. I apologize just a while ago. I messed up with an x and then x and d here. I decided to change this one from x into t here because I just don't want to confuse you. Yes. Yes or no? Okay.
Yes, sir.
So basically, the idea is that if I am following the rule of PEMDAS here, so meaning here I have to deal with this on the inner first, am I correct? Okay. So I don't see any number here. So meaning here this one is just only 1. Okay. So if you integrate 1, so it's going to be the t, am I correct? The variable itself.
Yeah.
Yes. Okay. So meaning what? Meaning t. And then after that, after I'm happy, I'm satisfied with the result of indefinite integration. So I need to plug in the upper limit and lower limit, right? So the upper limit has to be subtracted by the lower limit. So this is what we got. Yes. And then once I finish with this one here, all I have to just plug into here, my friend. Yes or no?
Yes.
Yes. Okay. So it's going to be mx minus gx dx. That's it. So it is exactly the same thing, just like the way that we did in calculus 1. Yes or no? Make sense or not? So I would like you to understand this concept because I am going to use this concept over and over again. The textbook never use this one, but I find this one very, very fascinating, very, very useful, to give you a general introduction into the world of multiple integration. Yes. So let me repeat one more time about the warning that I gave you just a while ago. Did you see it? So this one here is single integral, simple integral, but this one is double integral. Did you see it? So this one here, the one that is inside the green bracket is what we call inner integral, am I correct? Yes. Did you see that I'm putting in variable as the upper limit and lower limit in the inside? I never put anything outside because we are not supposed to do it. Upper limit, lower limit here, yes, you can put in x, y, or whatever here, a variable here, or equation, whatever here, but you have to do it only inside. As far as the one that is outside, outer integral is concerned here, you need to put always number. Never happen, never the other way around. Always happen. Everybody okay?
Yeah.
Okay, so again here, I'm not very surprised. Okay, so if you have problems, difficulty grasping, understanding this concept, because this one is so brand new. But don't worry about, well, having difficulty to digest this one, because, well, eventually you're doing it over and over again, eventually you get used to it. Yes.
Yeah.
Okay. But I just want to make sure that you at least that this idea is actually very foreign, very a bit crazy, but acceptable, comfortable. Okay, makes sense. Okay. Okay. Let's based on this one here. So let me do one example. Okay. Okay, so the example I pick up from the textbook is kind of very unique. It goes like this. So this one here is example number 3. Example number 3. Okay, so you need to find out the area. Remember here, so we are going to use this one to find out the area. Okay, it's not necessary, but again here the textbook is using this one as a general introduction into the world of multiple integration. Okay. So the example number 3 here, so this one is y and this one is x here. So look like that we got this one, this. Okay, so this one here, x equal to a, and x equal to b here. And then let's say this one is y1 equal to b. So this one is d, this one is c, and this one here, y2 equal to c. Okay. So we need to find out what is the area here. Okay. Well, you don't have to come here. You don't have to learn calculus 3 because in high school you already know it. Okay. So in order to find out this one here, okay, so all you to just, well, what is the distance here? Okay, that one is actually b minus a. Am I correct? Yes or no? Right. So this one is b and this one is a. Of course, the distance from a to b is actually just only b minus a. Right. Okay. Now, so what's this distance here? I mean, what is the length of this one? Well, this one also the same thing is going to be, well, b minus c. Am I correct? Yes.
Yep.
Okay. So what is the area? The area here, of course, is going to be this one and this one. It's very simple. Right. Okay. So it's going to be here b minus a times b minus c. That's it. Okay. But we are, I mean, the textbook is asking us to use what they call the double integration, or I should say, iterated or repeated integration to find out the area. Well, it's going to be very simple. Now, so let's focus on B and C here. So this one here is actually a horizontal line, and this one is horizontal line. Yes. So in that case here, so this one here is, well, if I am representing this line with an equation, so this one should be y equal to b. Am I correct? This is the equation. Am I correct? Yes. Okay. And this one also the same thing here. This is not the equation. So let's pretend that this one is y2 equal to c, and the one on the top is y1 equal to b. Okay. Yes or no?
Yes.
Okay. So in that case here, so this one here is actually exactly the same thing that's like the way that I explained just a while ago, like this. Right? Yes. Okay. So here we are talking about, this is actually the area between the two curves, right? It just happened here, the first curve is horizontal line, and the second curve is also horizontal. But that down the line here, I mean at the bottom here, this one I can consider this one as a the first curve, just like this one here, that's like this one is x, and this one is gx, right? And this one here, y2 here, is going to be gx. So we have to find out the area between the first curve, which happened to be a straight line, and the second curve, which happened also to be a straight line. So what is A and B? A and B is actually the interval. This is the beginning interval, this is the ending interval.
Yes.
Yeah.
Okay, so in that case here, so what I'm getting is that, well, it's going to be here. Well, so let's begin with the single integral and then move upward into double integral. A, B, am I correct? Yes. It's going to be y1 minus b equal to b here, minus y2 equal to c. Yes. Yes or no?
Yes.
Okay. And remember here, I intentionally using this weird notation because I just want to make sure this one is actually not just only simple b, but this one is actually an equation. These are also an equation. Excellent. Yes or no?
Yeah.
Okay. And then just like the way that I did, yeah. Okay. So I can convert this one here from single integral into repeated iterated integration. So it's going to be here a, b, okay, integral, okay. So it's going to be y2 equal to c, and then y1 equal to b, and then dx. Yes or no?
Yes. And then you're just integrating one, right?
That's correct. That's correct. Okay. Yeah. Hang on a second. Okay. dy dx. Right. So again here, the same thing happened here. So this is what they call inner integral. Am I correct? So inner integral, it is okay for you to have upper limit or lower limit in terms of equation. That's fine. But as far as the outer integral is concerned here, you cannot have anything that is non-constant. So do not ever try to put in x or x squared or y, whatever here in the upper limit or lower limit. Impossible. Right? Here is also the one that is very, very simple to follow this. Okay. So whenever you have double integral like this, so let's say something, something, whatever here, and then dx, dy, let's say. Here. So these two here make up the inner integral, am I correct? Yes. Okay. And then of course here, this one go to here, and this one go to here. So meaning what? Meaning here, this one should be x equal to something, 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 and then x equal to something, something. And then this one also the same thing here. So this is one package about the inner integral. So let's talk about the outer integral. Same thing here. This, okay. So this one go to here. Okay. So this one should be y equal to something, something, y equal to something, something. External. Because the dx here, of course, the upper and lower limit has to be in terms of x, of course. It is impossible to have the x and then suddenly you have y. Impossible. Yes. Okay. Just like this one, you see. So this one is the y here, and then you got, well, you got y equal to something, something, y equal to something, something. And of course here, from here, you can also say relate here. Okay. You see, b is actually is on the x-axis. Oh, that's correct, because it's on the x-axis. So that's why we put in the x. And a here is also on the x-axis. Here on the x-axis. Right? So by drawing a line like this, so you can avoid making mistake. Okay. And keep in mind that whenever that this one is x, this one should be x equal to something, equal to something. And if this one is y, it should be y equal to something, something. Makes sense or not? Just like this one here. Just like this one. Okay. Okay. So this one is y equal to b, and then y here equal to c, and then well x equal to b, x equal to c, equal to a. Sorry. Are they correct? Yes, they are correct. Because remember here, this one belongs to outer here. It goes, this one is egg, and then if you link up here, if you connect the egg into here, it is correct because egg equal to B is correct. Right? And here also the same thing here. If you link up here the egg and the egg here, well, egg equal to A, this one is also correct. Right? Make sense? Okay. So the answer to this question is that, well, this is actually the setting up for the integral, double integral in order to find out. How do you solve it? Well, again, the same thing happened here. First of all, you need to solve for the inner integral. So what is the inner integral? Inner integral is going to be equal to integral. Well, again here, you don't have to write on y here because it is understood. Whenever the b is y here, so everything lower limit, upper limit has to be also in terms of y. So it's going to be b, c, dy. Pretending that this one is 1. Okay, so it's going to be equal to what? It's going to be equal to y, okay, c, b. Okay, so this one is equal to what? It's going to be equal to b minus c. Right. Okay, I'm done as far as inner integral is concerned here. So let's put the result I got from the integral, plugging in, inserting into the outer integral. So the outer integral here. So I got here a, b, right? Okay, and then b minus c, dx. Right. Okay. Well, like it or not, b minus c is actually a constant. The constant, can you take it out? Yes, absolutely. So it's going to be equal to b minus c integral a b 1 dx. Everybody okay? That I am taking out b minus c from inside to the outside because b minus c here, even though it doesn't look like constant, but they are constant. Yes. Okay. Yes. So, and then after that here, what is after that here is going to be equal to b minus c, and then bracket, okay, x, and then b a. Right. Okay. So go ahead, plug in this. I got here b minus c. Okay, and then b minus a. Are they the same thing just like the way that we did in high school? Yes, absolutely. This is the one that we got in high school, and it matched directly. It matched precisely the one that we get from iterated integral. Make sense? Okay.
Yeah, it makes sense.
Okay. So again, just get used to it. Eventually, you will get used to it. Okay, so let me give you one more example and we are done here. Okay. So we almost have. And then, well, I just give you 2 examples, but eventually here, I think that we have to continue with and on Thursday here because, well, there's a lot of examples here we haven't done yet. Okay. Well, I think let's do this, okay? Hang on a second. This example is kind of a little bit long here. I don't want to get cut off in the middle. Okay, I just want to introduce here because we have only about 5 minutes to go here. Okay. There is such thing as what we call X simple and then y simple. Okay, so the idea is like this, I think that you already learned it in Calculus 1, but we never formally formalize this idea. So let's say that if you have a graph like this, and you need to find out the area of the one that is shaded here. Well, so let's say if this one is at here. Okay. Well, so this is what we call the X symbol. Why? Because it is very easy for you to find out the area, yeah, just by using F here dx. Yes, sir. But
Yeah.
on the other hand, so let's say if you have another graph, weird looking graph like this, the graph like this, and you're supposed to find out the one that's shaded, the one that is inside here. But this is what we call y simple, because that it is much easier if you just go ahead and integrate it with respect to the y. This is what we call y simple. Yes, sir. Okay. So this one here is going to be here. Well, it's going to be f. Let's say this one is gy. Okay. So gy dy. This is what we call the case of y simple. Right. Okay. But in some situations, sometimes that the problem, I mean, the graph is actually both. You can do y simple, you can do x simple, they are the same thing. So let me give you an example. So let's say if I have a graph like this, okay. So let's say this one here, so let's say this one is fx here, okay. And then if you have to find out the area here, the one that's inside here, well, this is what we call both simple. X simple, yes. Y simple, yes, because it is very easy. Well, let's say this one is A here, this one is B, and this one is 0. Well, so you can say that, well, A here equal to integral, right? Okay. 0, A, F, X here, and then dx, am I correct? Very simple, am I correct?
Yeah.
Okay, and then at the other hand here, if you would like, if you don't mind, if you're a y person, you can set A here equal to 0, B, and then F, you have to convert into y, dy. This is the case of either X simple, Y simple, they are the same thing. Okay, so let me. Okay, so everybody okay? Everybody understand this one is both X simple? Yes. Y simple? Yes. Yes. Okay. And here is another one here. Okay. So of course, to be sure here. So let's say this one is A, this one is B here. Let's say this one is F here. Okay. To be sure that if you have to find out the area here, okay, the one I shared it here, to be sure this one is, well, very X simple, because you can easily find out the area and be equal to A, B, F, X, dx. That's it. It's very simple. Yes. But on the other hand here, if you insist on using Y simple, well, you have to do it twice. So you have to do. So this one is A number 1, this one is A number 2. So I'm going to say that this one is very X simple, but not so simple in terms of Y, because that the area here got to be, so let's say, well, this one is 0, let's say this one is C, and this one is D, so meaning what meaning here? Well, so it's going to be integral, So let's go for A1 first. So I got C, D, and then F of Y, dy. So I got A1, the first area, am I correct? Yes? Yes or no? Okay, hang on a
Yeah.
second. Well, I think I have to subtract this one as well. I have to subtract this one. Yes or no?
Yes, you have to
Yes, okay.
subtract that.
Yes, and then plus integral 0 C, right? Okay, and then, so this one is going to be B and then dy as well. And then after that, I need to subtract this one here. Okay, it is actually very problematic, but I think I don't have to complete this one here, but you get the idea. This one is very, very X simple, but as far as dy is concerned, not so simple. So this one is both. This one is actually both way. X simple, Y simple. But this one here, X simple, but not very Y simple. So this one is totally impossible, almost impossible to do the X. So this one is totally Y simple. This one is, you can also say this one is totally X simple. Okay,
Got it.
so that's it. Okay, so see you again on Thursday next week. Okay, so everybody okay? Bye.
Bye. Thank you, Professor. Bye-bye.
Okay, good night. Good night.
Thank you.
Sure, okay, see you again Thursday. So I'm going to close the recording.